Welcome, everyone, to this great evening. I'm super excited about tonight. Got a great guest and a co-host of this training tonight, Gary McCready from HVAC Know-It-All. And tonight we're going to be talking about the basics of HVAC and refrigeration and the refrigeration cycle. Gary, how you doing, brother?
I'm awesome, man. How are you?
And I'm doing fantastic. I've been pretty excited about this event because we planned it, I think back in January, February, or maybe even January we planned it because I knew I wanted to do something with you, try to share some of our knowledge with the industry and kind of do a training, because I know you want to get more into the training side as well. You've been doing tons of training over the years. With all the stuff that you've been doing has been fantastic. And I thought this would be a great collaboration event for both of us.
Yeah, for sure. I've been looking forward to it, and I can see the blocks filling up of these people that signed up. So, guys, welcome, and we're gonna do our best to try to teach you something tonight.
Yeah,
We're gonna
yeah.
do our best, right?
Yeah, so it's just it's going to be a good old conversation, kind of like a podcast. Me and Gary, he's invited me on his show many times to do a podcast, but this is going to be a little more structured, I guess, a little bit structured, where I'll get some slides that we're going to share with you, and then we'll go through a few diagrams, kind of just review the refrigeration cycle. And please, if you have any questions, just throw it in the chat box. We're going to have a few little exercise for some of you. There's also a knowledge assessment at the end, so I'm going to throw a link in the chat box where you can actually do a knowledge assessment from the training. So I'm just going to share my screen now. See that, Gary?
Yep, I can see it.
Awesome. Awesome. So welcome, everyone. So tonight we're going to be talking about the basics of refrigeration and HVAC. We're going to go through some key terms, and then we're going to get into a conversation. We're going to ask you guys, hopefully you guys will have some questions at the end.
Well,
If it's
they will have some questions. So, guys,
yeah,
it's important to start thinking about your questions now and not think about them at the end. So, if you have a pen and paper, write down a couple of questions as we go, and then at the end we'll try to answer them as best we can.
yeah. And it could be related to the topic that we're talking about. If something about refrigeration and HVAC, we'll do our best to answer, like Gary said. So what we're going to go through tonight, I got today's up there. I've been doing a lot of day training, so tonight we're going to talk about some key terms and definitions. I think this is really important, especially if you're newer to the industry or even been in the industry for a long time. Some of the terms you don't really think about all the time, and you may know them, but it's really nice to do that review. I've been doing a lot of review lately, Gary, just to really brush myself up because I really believe the foundation and the basics of refrigeration and HVAC is so important. I believe that's so important to really excel yourself at the more advanced refrigeration and HVAC terms.
Yeah,
What do you
if you
think?
don't know the basics, don't try to learn advanced because you'll never understand it. Basic basic fundamental principles of anything in this trade, refrigeration, electrical, gas, you need to know those, and if you know those well, you can solve any problem by going back to the fundamentals always.
Yeah, and I really believe to do that consistently, even now, like I've been in the industry 18 years. It's crazy, and I love doing these trainings because I'm going to learn a lot tonight. And even tonight, every train I've done trainings like this many times. I'm going to learn a lot tonight, which I'm excited about. We're going to get into the refrigeration cycle. We got a enthalpy diagram that we're going to walk through. It's one that I built, and I really like the way that we're going to walk through. We're going to talk about different things, and if you have questions on it, please ask. Like Gary said, ask the questions because you may not have seen an enthalpy diagram for years. I didn't
I
see.
I haven't.
There you go. Gary hasn't. So it's a good way that we're going to strike up some conversation. We're going to go through some of the main components, and then we'll do a system checkpoint review. We're going to ask you, like, what do you guys check when you're out in the field doing service, doing troubleshooting? And we'll get into a Q&A, and I'll send you guys the knowledge assessment if you want to take a crack at it. Totally up to you. Okay, some of the key terms. Any questions before we get started, Gary? You got any questions? Anybody have any questions? Check the chat.
I'm good for now, man. I'm
I
good.
love it. I
What's the
love it.
chat saying? Anything in the chat yet?
Nothing yet, but we're going to get that blown up. We're going to do a little chat burst. I just learned this lately, a chat burst, and we'll do one later. A lot of people are, what's a chat burst? But we'll do a chat burst. So what is, okay? So this is a kind of an enthalpy diagram. I call this the thumbprint. You may have seen this before in school, if you've been to school or any refrigeration book. And so this is an enthalpy diagram here. So we got our four main components, which we're going to talk about again later. I'm going to ask you again. But this is plotted kind of on an enthalpy diagram. So sensible heat, something pretty important to know, but what's sensible heat? And I'd love to see it in the chat. You can unmute yourself if you want to have a conversation and answer it. That's totally fine here. We're open to that. But if you want to throw in the chat, what is sensible heat?
Hey, and guys, if you're wrong, nobody's going to make fun of you. That's we're here to learn. So if you have a
heat,
you
can measure.
Put your hand up. You want to talk? Go ahead.
Yeah, for sure. Heat can be measured. Measurable heat, exactly. Okay, where do you find those on an enthalpy diagram? Maybe I should even open up to annotate. If nobody's reckless here, let me. I'm going to just even open up to annotate. We'll be here for 4 hours sometimes when I start training like this.
I hope not. That's like midnight, man. What are you doing?
So measurable heat. These are different locations, right? Different locations here, here, and here, where you can take your probe and you can measure that. That's, like you guys said, measurable heat. Anything that you can use and like a temperature probe and measure it. Latent heat. This is something super important. And this took me, Gary, many years to understand latent heat. You know, it's been told to me over and over again, but I'll tell you, the first quite a few years before it really clicked what latent heat was.
Yeah. Anybody want to tackle this one? Anybody in the chat? Anybody want to put their hand up? Oh, I heard someone say something. Was that?
Oops. Shit.
Robertson, yeah.
I said witchcraft. Sorry, I should have been muted.
Witchcraft.
Well, yeah, I used to think it was back in when I didn't really understand it. Constant temperature change of state. Well, there we go. We're getting there. You know, change of state. What do you think, Gary?
Well, I mean, when we're dealing with latent heat in the summer, right? If you've got a large latent heat load, your AC is going to tackle that load before it starts to drop the temperature in the space. Let's say the space is 75, but you have a large latent heat load. So your AC is going to tackle that latent heat load, which is in the form of moisture. And we're talking about when we're removing latent heat, we're removing moisture from the air. Once it gets rid of that latent heat, then it's going to start tackling the sensible heat and then start dropping that thermostat, the reading you see on your thermostat. That's sort of maybe like a simple way to describe it.
Yeah,
in the form of air conditioning.
Yeah, no, it's like really any energy absorbed during any energy absorbed or released by a state change. So when it's changing,
causes change of state, correct?
Yeah, so you're changing from a vapor to a liquid to a vapor, and that's really what. Where does that happen? So on this enthalpy diagram that you see over here, where does that happen? Where would you see that?
My cursor works too. Okay, cool. So this would I haven't seen one of these diagrams in forever, but it's going to happen on the outer portions of this curve, right? It's going to happen here. And it's going to happen here.
So anywhere where there is outside the thumbprint. So out here, right along all these places, I showed you guys earlier, sensible heat, latent heat. So anything inside the thumbprint, because that's where your saturated conditions is. And I just gave an answer probably, I think, for the next one. Saturation conditions. Where's your saturated? What is the saturated condition?
Saturated condition. Well, for the way I like to talk about saturation is when you're looking at your gauges. if you have your gauges hooked up to a system, and we have 100-degree condensing temperature, whatever refrigerant you're using, the pressure that corresponds is your saturated state. That's what your gauges see. Your gauges see saturated state. So basically, that's the boiling point of the refrigerant.
Yeah. Anytime there's vapor and liquid are in the same closed space. So in that evaporator, like Brett said, yeah, condenser and evaporator, exactly. And so, like you said, Gary, you put your gauges on the, say, on the exit or the outlet of the evaporator on that suction line. And you get that pressure. That would be your, some people say SST.
Yep, saturated suction temperature, correct.
Right. So the one big thing about refrigeration and HVAC, there's a lot of terms. It's kind of like the English language. You say one word and it means 5 different things. So sometimes in refrigeration, when you're talking about something, there's a lot of different terms. So it's good to understand the different terms. And that's anywhere inside here, right? Where you have both liquid and vapor. Superheat. What is superheat? Superheat's super important to know too.
Yeah. Who wants to tackle superheat?
It's outside of the top of the right curve.
Sorry, what was that? I didn't hear that one.
It's outside, towards 1 and 2, outside of the curve.
It
Yeah,
is,
yeah.
but let's.
Yep.
You're correct. It is outside of the curve there. But if we're talking about superheat in a practical sense, and we didn't see this chart, what is superheat relative to saturation?
Both Brett and John said it in the chat.
Did
Your
they?
temperature over saturated suction, your pipe temperature over your saturated suction temperature, pardon me.
Yeah, there you go.
Yeah. Yeah, no, exactly. So heat added above the boiling point.
And
Heat added
remember,
above
it's not just pipe. Superheat can exist with anything. It can exist with water. So it's just basically anything above saturation is what superheat is. Because superheat can exist not just in refrigeration and air conditioning, it can exist in other realms of science as well. So just keep that in mind. And anything above saturation.
Dew point. This is a good one. I like talking about dew point because this is going to be really important to understand. Very important, especially with all these new refrigerant coming out. And you, as a technician, a newer technician, an older technician, or experienced technician, you really need to understand these new refrigerants because there's so many of them. I mean, so many. If you go and get the Danfoss app, I highly recommend having the Danfoss app, and you go and look at their PT charts. You scroll for like 5 minutes and all the different refrigerants that are out there. It's wild.
Yeah, their PT chart, their ref tools PT chart is the best one in the industry. If you guys want a good solid PT chart that has tons of information, the Danfoss one is your go-to for sure.
Oh yeah. So dew point, what is it?
I think dew point and bubble point are confusing to a lot of people. I think that maybe the term glide might help.
Yeah, we'll get to that.
Yeah.
That's in here. Yeah.
Okay, perfect.
Yeah. We'll get to that. So the dew point is important to understand. And I know if somebody knows it, I'm gonna. Robertson, go ahead.
Well, at your dew point, anything below that dew point temperature, you're going to start condensing.
Mm-hmm.
You're going to start condensing, condensation. Sorry, creating condensation. Pardon me.
Yeah.
Work on a building. They got some in-floor cooling actually down in Halifax, and there's alarms on it, so it's got to keep the temperature of that above 2 degrees above the dew point, or you're gonna have some slippery floors.
Yeah. So the dew point is, let's see, high dew point equals less evaporatability. Yeah, that's a good way to look at it. It's really the vapor state. Go ahead, Greg.
I was going to say, I think maybe like I think Robertson was talking about dew point in the terms of like dew point of the air and a cold surface and condensation. I think that we should clarify we're talking about you're talking about dew point in a blended refrigerant, right, Trevor? Is that what you're talking about?
Yeah,
Okay.
so you have a dew point and a bubble point. So the dew point is the vapor state of the refrigerant. And this point is what you use to measure superheat. Remember that. The dew point for superheat. And this confused me for years, and it still confuses a lot of people. You use the dew point to measure superheat. So with high glide refrigerant, when you're going to measure that superheat, you make sure you use the dew point. And here's where it is. So remember we talked about superheat over here, and this is your dew point line right here. So this here is all vapor. So the dew point is vapor.
And that will,
Superheat and bubble cool, and Brett puts it in the chat. So that's one way to look at it. But just remember that anytime you're checking superheat, you always use the vapor point or the dew point. And it depends on the PT chart you use. I guess you're all probably using all like apps now, which makes it a bit easier. Make sure you use the vapor point or the dew point when you're checking superheat. Go ahead, Gary.
yeah, no, I was gonna say you're bang on there, and that's a good way to remember it. Bead Brett, duper heat and bub cool. So yeah, so if you're checking superheat, duper heat, go to the dew point. If you're checking subcool, bub cool, go to the bubble point.
Yeah. So where would we find subcooling on here now? Like I got 1 to 2, 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 1. Where would I find subcooling? And what is subcooling?
While we're waiting for answers, these charts are actually really good if you
I
want to
got an
troubleshoot.
answer.
Oh, okay, there we go.
Sorry to butt in.
That's okay.
Yeah, no, please.
Subcooling would be between 0.3 and 4, that little green dot.
100%.
Yep.
100%. And what it? Yeah, keep going.
The definition subcooling would be cooling a refrigerant below its condensing. Sorry, no. I just got back from school. I should know this.
That's you were right on there. You were saying it.
Yeah,
No, you stopped yourself.
Cooling your liquid below your condensing point, but it remains a liquid.
Yeah, so anything below that saturated temperature, the opposite of superheat.
Yep.
So right here, you're 100% right, Ethan. So here's your condenser here. This is the outlet, your condenser. You should always at the outlet of that condenser have like a high pressure, high temperature liquid leaving there. So it should always be leaving your condenser as a liquid because you do not want flash gas in that liquid line. Right, so it's always important to check your subcoolant at the outlet. What else do we got here? So this is subcoolant. Great job, Ethan. Bubble point. Where's the bubble point at? So I showed you where the dew point was. Where do you think the bubble point would be on this drawing? On the right side, so over here on this side, or on this side? Maybe I gave that away pretty easy there, Gary.
Well, while we're waiting for, oh, there you go. I was just going to say that these charts, you can actually plot, like take your system readings and plot them on the chart that the chart. Each one of these charts has their own refrigerant from what I remember. And these are actually really good troubleshooting charts. If you're having trouble with a system, you take your readings and you plot it on this chart, and you can actually see it, what it's doing, and look at it and get a full on visual of the entire system with this chart.
100%. I highly recommend doing that. That's something different that most technicians don't do, and it's sometimes it's difficult. But with technology today, it makes it so easy. I'm going to talk about in a few minutes about Cool Selector 2, a free app from another one from Danfoss that you can use. And Emerson has them and Bitzer has them as well. I'm learning new softwares, and I think they're really cool to get those enthalpy diagrams. We're going to show you one. But when you start plotting stuff like that, it's going to make you think a little bit different as a technician. Because that's how more things start to click for me when I'm actually doing more of the design and engineer side. And I highly recommend look into some of that stuff as a technician. You should understand how to plot your pressures and temperatures on a chart like this, because it's going to open your mind up to think differently about the refrigerant and refrigeration and HVAC.
Yep. No, 100%. And like, let's just say, for instance, this is a regular type subcooling right here is what you see. And every time you draw it, this is what it looks like. And then you draw it and it's like way out here. You're like, whoa, something's not right here. Right. And then that's where you can get a visual of it being way out of whack type thing. Just as an example.
So let's get to the next one. Glide. This is a good one.
Yeah.
Glide. What's glide? And glide is something that it took me many, many, many years to understand. And you got to continue to look at it in different ways, the refrigerant. Because the refrigerants today, most of them that are coming out, the synthetic ones, they have higher glide.
When refrigerants are mixed and they have different like bubble points and dew points.
Yeah.
Yeah.
Yeah, that's I can anyone else that's correct, but there's something you just missed when you said that.
Does glide refer to specifically just the evaporation stage?
No, that's glide is the I can read you something. I don't know if I should read it now or wait till we chat about it, but glide is the refrigerant itself. It's got different components to it. And basically it's the boiling point of the least volatile across to the most volatile. And there's a gap in between the two.
Yeah. So if we look at this line right here, right now, so for example, R22 is a single blend refrigerant. It's when you think and talk about R22, it's a single blend. And you'll look at here, this is a temperature right here, at this point right here, and this is a temperature. So I'm just making up numbers. Say at 50 psi, it's 20 degrees here and 20 degrees here. Bubble point's 20, dew point's 20. When we talk about glide, this is what it looks like now. We have different temperatures, same pressure.
Yep.
Different temperatures, same pressure. I got a bubble point temperature and I got a dew point temperature. Hopefully everyone can see that where my cursor is. And that's really what it is. The range of temperatures between that bubble point and that vapor point. And here's the condenser side. So the top one's the condenser, the bottom one's the evaporator. So it doesn't matter. What you need to understand with glide, you always do superheat with what point? We said it already. When I'm checking superheat with a glide refrigerant, you want to check it with what? You can throw it in the chat. You can unmute yourself because this is important. Dew right here. You want to do it right here because you see here, this is a different temperature. And if you use this point, you're going to have that wrong temperature. And if you make the mistake, it could be too high of superheat or you could be flooding back to the compressor. Okay? And you always need to use the bubble point for subcooling. So there are situations where you will use something called the average or the midpoint. And this is where manufacturers are having a huge, it's difficult to design certain coils with certain refrigerant because the glide is so high. There's like 15-degree glide in some refrigerants and some even higher. But when we talk about newer refrigerants that been out for many years, but 448, 449, you may have heard of them, they're up between 8 and 10 degrees glide, I believe. 407A, 407F, 407C all have high glide. You may have heard of some of those refrigerants before. So you need to understand that. And then when I talk about the average point, how you get the average point, you get your bubble point temperature, you get your dew point temperature, you add them together and divide by 2, and that gives you your average or your midpoint. A lot of apps give it to you automatically. But when you're setting up certain valves and systems, you need to start with that midpoint. For example, an EPR in refrigeration, it's evaporator pressure regulator. So it holds an evaporator at constant pressure, but you would start with that, for an example, at the midpoint. Then you adjust it to temperature. I adjust everything I do when I'm working on refrigeration now, I do in temperatures. People tell me pressures, I'm like, what's the temperature? Because we're really dealing with temperatures. More so important, if you get in the habit of troubleshooting by temperature, especially with all these new refrigerants coming out, when you're talking to another technician, it's going to make it a lot easier. Oh, it's
Exactly.
110
Exactly.
Fahrenheit condensing, not, oh, I got 275 PSI. That means nothing to me. What refrigerant now? But if you tell me a temperature, then I can comprehend it. You feel the same way, Gary?
This is something that I've been telling techs for a long time that ask me questions. They're like, what should my pressures be? And I'm like, well, you know what? I don't know what refrigerant you're working with, but I can tell you what if you're working on AC, I can tell you what your saturated suction temp should be. It should be 40. So what pressure does that correspond to? So don't worry about the pressure, because 410A, RS44, R22, whatever you're using, you want to maintain that same evaporator temperature. And depending on, I guess, what you're working on, your condensing temperature in AC is going to be 100 to 110 degrees Fahrenheit. So it doesn't matter what the pressure is. Maintain your temperature, your saturated temperatures, and you'll be fine. And when you talk to other techs, use temperatures as well. I just find it's the best way to figure it out rather than relying on pressure.
Yeah, I love it. Temperature difference, TD. So this is important to understand, because you could talk to someone and say, what's the TD? And you're talking about two different things, right? Some people think of TD in one way. Some people think this is how you check it. And this is compared to I guess, air conditioning compared to refrigeration. So what is TD? Love somebody to, when someone says, what's the
Temperature difference?
TD? It is the temperature difference, but between what?
Yeah, see,
The-
we're getting mixed answers. I think are we, Trevor, is Delta T on here too? Is that next?
No, I actually don't have Delta T on here. I did, but I removed it.
Okay,
This is
because
from one of my refrigerators.
I think we're gonna have to explain the difference between the two, so they
Yeah.
don't get confused. Because I seen somebody say the difference
Yeah.
between the air in and air out. I thought,
Yeah.
supply and return.
Go ahead.
So Delta T is the difference between the same medium. So let's say air is passing over a coil. The delta T would be the difference between the return and the supply. Or if water is passing through a coil, it's the same medium in and out. That's your delta T. When we're talking about temperature difference, it's the difference between two different mediums. So in this case, it would be refrigerant and air. So for air conditioning, it could be the difference between the saturated suction temperature and the return air, for example.
Yeah.
Trevor?
Exactly. And then lots of people say it in there, like box temperature and coil temp, return air, and SST and
Yep.
minus return air. So that's why it's important to understand, because, to be honest, it took me a long time to figure that out too. When I was talking to someone, we were talking about different things. So it's just good to understand that stuff. And that's why I threw it on there.
No, it's a good one to have.
High side as well, 100%, Brennan. High side as well. It's you need to
Yep.
understand. So my quick example, I got one here, is you have a 25 degree Fahrenheit coil or -4 Celsius, and the box temperature is 35 degrees Fahrenheit or 2 Celsius, and the TD would be 10 degrees Fahrenheit. So the coil's 25, the box is 35, so that return air, and you get 10 degree. And I actually have it here in my notes. Delta T is air in versus air out. Awesome. That was awesome. Way to go, everyone. Really appreciate that. Oh, a bonus one. A bonus one. Look at this. Compression ratio. Compression ratio. What is compression ratio?
Absolute suction pressure, or sorry, absolute discharge pressure divided by your absolute suction pressure.
100%. 100%. And that's so important to know, because one thing that I didn't really understand and take into consideration when I was troubleshooting systems when I was in the field for many, many years is compression ratio. And when I worked for a compressor manufacturer for many years, that's where it really hit me and realized that compression ratio is so important. And most compressors fail because of issues with compression ratio. And if you don't check that, you don't really know what's going on with the compressor. And you can go to any compressor manufacturer, you can go to Copeland, Bitzer, Danfoss, Tecumseh. They will tell you, you need to understand that compression ratio. Too high compression ratio, too high discharge is going to cause higher compression. When you have high compression ratio, what does that cause? That's a good question. High compression ratio.
High temps, hard work on your compressor.
Yeah, heat, high temps, more work on that compressor. You're pushing it hard. And okay, here's another good one. Is it worse to have high discharge for compression ratio or a drop in suction pressure? So increase in your condensing pressure or temperature, or drop in your suction pressure or temperature?
Drop in your suction pressure.
100%.
No oil
One
return.
is suction pressure. And it's going to skyrocket that compression ratio really quickly. And that's why it's so important to understand pressure drop. Pressure drop in your suction line. I've seen it many times, field supporting, where they got the wrong suction line. From the evaporator to the condensing unit, there's 12 or 15 PSI pressure drop. You're going to run into major issues.
Not having the time.
Hey, since this was a bonus, let me give a bonus trick question if
Daily
everybody's
double.
up for it. So let's say our compression ratio is 3-to-1 on a regular basis. And every time you go check that thing on a maintenance or whatever, it's 3-to-1. But one day you go check it, you get a service call, it's now 1-to-1. Most likely what has happened to that compressor?
Well, it's not moving any refrigerant.
Well, you got it. You said it.
There's
It's
no
not
gas.
it's not pumping anything.
It's not pumping nothing. Okay.
It's not pumping anything. Usually what, like on the older, like for me, like I've worked on a lot of recips, and the valves can go bad on a recip. You can blow a valve up if you get a slug of liquid or whatever. And if the valve goes, basically you're not going to pump refrigerant. You're going to equalize the pressures across the high and low side. The pistons are still going to move up and down, but you're not going to pump any refrigerant. And in a lot of cases, Trevor knows this, we've talked about this with scroll compressors. If they get warm enough, they can actually still run, but the scrolls disengaged and they don't pump. And a lot of people get tricked and think the compressor's dead when it's actually not. It's just hot. The scrolls have disengaged. You put your gauges on, the pressures are like equalized on both sides, but the compressor's fine. You just got to let it cool down, and it could take hours for it to cool down unless you have a hose on the roof to soak the thing.
Yeah, 100%. And that's one big thing about scrolls. You know, if it has advanced temperature scroll protector or ASTP, it'll have a big sticker on it. It could be off on that. And compression ratio is huge on the scrolls because there's something called inside there called a floating seal, and it's designed there so the scroll doesn't go into a vacuum. So what happens when you get a high compression ratio, it separates the scroll. So there's a lot to it, but it's good to understand that. Yeah, broken valves, like, yeah, great.
This is what happens when you're like a lot of units when you're trying to pump them down, like you're holding in the contactor and all of a sudden it just stops.
You can't, scrolls aren't to be pumped down. So refrigeration scrolls, well, Copeland anyway, are designed to for 26:1 compression ratio. So it gets up to say 25, 26, and when you get over that, it's gonna separate. And because what'll happen, it unbalances the floating seal and it separates. On air conditioning scrolls, 11:1. So if you work on 410, like Gary just said, it's like 3:1. 3:1, 4:1, all the time. But when you get up to 11:1, that's when it's gonna unseat, it's unbalance that floating seal. So when you're on your AC unit, you're trying to pump it down, and all of a sudden you get down to 25 psi, and all of a sudden it goes to equal. That's what's happening. You're just there's nothing wrong with the compressor. You're putting an outsized envelope. So I got a polling question I'm going to launch here for everyone. Hopefully you got that. Question: heat transfer only takes place when the doors are closed, the fans are running, the power is on, or there is a temperature difference. Okay.
Definitely when there's a temperature difference.
Yeah, there you go. Excellent. Look at you guys crushing. I'm going to end that poll. Everybody got it right, so great job. Great job, everyone. Oh, and there was my polling signal. Okay, we already went through this. What's the main components of a refrigeration system? Because there's many components, and it depends on what system we're talking about. But there's 4 main components in every refrigeration system. And when someone says, oh, I work on heat pumps, that's a refrigeration system. I'm working on an air conditioner, that's a refrigeration system. They're all refrigeration system, only some are higher temp and lower temp. So what are main components? I talked about them already, so this should be easy for everyone.
Compressor,
Yep.
condenser, evaporator, and metering device.
100%. So these are the 4 main components. We got a compressor, we got a condenser, just like Ethan said. We got a metering device, and there's many different types of metering devices, and then we got an evaporator. So if I was going to put a line to separate the sections, where would a line go? Because this is important to understand this. Like if I'm going to separate high side and low side, where would this line go?
Before the compressor and before the metering device.
So something like this. You'd say high pressure, high temperature on this side, low side pressure and temperature on this side. Make sense? Because can you see a low pressure side or low temperature on the high side? And if you do, what's the issue? I may not ask that question very well, Gary.
Yeah,
But-
repeat it for me because my screen was on the Tinker. I was trying to fix it there.
So can you have low side pressure or lower pressures and temperatures on the high side? And if you do, what is the issue?
Can you have lower pressures on the high side? Is that what you said?
Yep.
What do you mean by lower pressures on the high side?
Lower temperature. Or,
dryer.
there you go. Yeah, that's exactly right. Maybe my question wasn't very good, but 100%, it's in there. Filter dryer restriction, dirty condenser. Restriction, Brett said there. I missed that one. So exactly. So having that lower pressure or lower temperature on the high side is due to some sort of restriction. And you'll see it sometimes, and I've seen it doing field support many times. A guy calls me up and he'll say, "Hey Trevor, I've never seen this before, but my liquid line is cold and my suction line is warm." Okay? And I've seen it before where the condenser's plugged. I don't know if any of you have seen a condenser plug, but you get plug in the condenser and then it's going to be flashing in there. Now you got a metering device inside your condenser, or you got a plug.
You're talking about
filter
an internal plug in the condenser.
Mm-hmm.
Yeah.
Inside,
Yeah,
not not dirty condenser, not like dirty. Sorry, not dirty plug. Internal in the piping, and it's flashing the gas.
Had that
And
happen just yesterday, Trevor. Had non-condensables and a microchannel condenser 3 stories up from the unit that's in the basement. Similar
wow.
symptoms that you were just saying.
Is that Waxer talking in the background?
Yeah, it is, Gary.
Hey, what's up, man? I didn't
How's it
see
going,
your
brother?
I didn't see your name. I didn't see your name pop up in the beginning.
I just joined in late,
Oh, okay.
work-related stuff, so glad to finally jump on.
Awesome.
I'm glad to
Yeah.
have you. I'm glad to have you. But yeah, exactly right. So look, Matt just gave you an example of yesterday of it happening, and this can trip you up. I've had guys that were very experienced to be like, I don't know what's going on. Why is this happening? But you got to think when you can start thinking about inside the pipe, like you being inside that pipe, you being the refrigerant, and it takes experience. Don't get me wrong; it takes a long time, and I'm still learning. I feel like a newbie a lot of the times, but
I just somebody sent me a video. I did like I did a TikTok. I can't believe that HVAC is happening on TikTok these days, but it is. It's a growing platform. If you guys aren't on TikTok, there's a growing number of skilled trades getting on there, like there was on Instagram kind of 4 or 5 years ago. But anyway, I did a TikTok of just explaining the filter dryer thing and checking across it, and somebody sent me a video, and the liquid line was actually frosted after it was an air conditioning system frosted after the liquid line, or the liquid line filter dryer, because it was so plugged. Like Trevor was saying, it was creating a metering device, and it was frosting on the outlet all the way up to the metering device. It was crazy.
yeah, and you can see that out. I've seen it before. So, okay, this is another enthalpy diagram. This is from the Cool Selector 2 app. You download it on your computer. You can get any manual from Danfoss there, but this is the enthalpy diagram that we talked about earlier. And I want to kind of walk through this on how the refrigerant is going through a system. So here's the refrigerant. Think of this little red ball as the refrigerant. That compressor turns on. You get power to it, and it starts up. And what happens is you get something called a heat of compression. Okay, that compressor takes that gas, that low pressure gas, starts to squish it, compresses it, this is a vapor, and discharges it out. What happens next? Right when it leaves that valve, that compressor valve, what happens? What starts to happen to the gas?
Picks up
Right.
heat.
Or
Superheats, yeah.
Desuperheats 100%. So all this rate, the hottest point is right when that last squish of gas in any compressor. That's the hottest point. After that, it's all desuperheat. So as it leaves, it's desuperheating. Desuperheating, boom. Then we hit, what point is this? We talked about it many times.
Condensing.
Condensing, but what was the name that we said? This line right here. This is all vapor. Dew point, yes, excellent. So we hit the dew point. This is right now. Now we start to what? What's happening right when we hit that? We hit the condenser. What's happening? Condense. We got droplets. Droplets coming out of that refrigerant. You got to think of that like you're the refrigerant. As it starts to go through the condenser, it continues to condense, and then what? And we hit this line. Yeah, well, subcooling will happen, but subcooling's not happening yet until we hit the bubble point. Yeah, so Brendan put it in there. We're hitting the bubble point. Only after that bubble point is when we start to subcool. Right here, just like we talked about before. What's the next step? What line would this be? What's this line right here? So if you're in a residential system or air conditioning, what would we call that line?
Where are you talking, between the 3 and 4?
Yeah, sure.
The liquid line.
There you go, liquid line. Could be the drop leg, condensing line if you're in refrigeration.
The drop leg, I was listening. Yeah, the other day I was listening to Brian Orr saying, they kept saying the drop leg.
Yeah, so different application, like people talk different. So you want to understand the different terminology when you're talking to people. So you do the pressure drop here, metering device. It could be a cap tube, it could be TX valve, could be electronic expansion valve. We're seeing so many electronic expansion valves out there. I am, and if you're in the VRF world or VRV world, it's all electronic valves. So you're going to see more and more of that. We get back into the saturated curve, your thumbprint. You're back into your SST. Oh, and then that evaporator starts to absorb the heat from the product, from the people, from the room, and then we hit our dew point again, and then bam, that's your superheat right here, 5 to A. Yes, you're right. Between the receiver, though, you're right, Brett. That droplet condensate goes back to the receiver.
Also known as a condensate line, and that's actually the only place a lot of people don't know. I said this a few years ago, and people laughed at me online, but that condensate line, or drip leg, as some people call it, is the only place where refrigerant will flow in both directions in a system. Because out of that condenser, you have liquid dropping down into that receiver, from the condenser, and then you have vapor moving up from the top of the receiver back into the condenser. Just like if you were to pour out a bottle of water, the water's leaving, but there's air going back in, which is actually forcing the water out. A lot of people don't know that. It's a really interesting. I think there's a DuPont refrigerant piping book. You can find it online, and I think there's a part in there that explains that.
Yeah, it was that book was written by I was just talking in a training about it the other day, because I passed it out in some of my trainings. I put the link in there. Garth Dennison.
Isn't that
That's
also called
Garth Dennison.
called sewering, Gary?
Sewering? I've never heard
Yeah.
that term. I've never heard that term before.
I've heard that thrown out a couple times in school to explain the bidirectional flow within the condensate line that we're talking about.
Okay, I've never heard it called that before. What, sewering? Like how would
like
spell
like
it?
the sewers in your street.
Okay, gotcha.
Interesting.
Okay.
I'm gonna look that one up. So these are just really, that's how the enthalpy diagram works. And there's, like, you see a lot of this red and green lines. They all mean something. Engineers use that all the time, but the main ones that you're going to use is like this red line. And you notice this is 407C. Do you see how this red line I have is straight, but you look at the 407C line and see how it's in a different, it's on an angle. So here's your bubble point temperature, here's your dew point temperature. They're different. So it's good to know that stuff. Okay. In the chat box, I got a system checkpoint review, because we're going through time like real quick here. But in the chat box, put what the points you would check. So I'll give you a couple quick ones. Suction pressure, suction temperature. So throw some in the chat box. And other things, when you're out in a service call, you're setting up the system, you're doing an install, you're doing a commissioning, what are some of the checkpoints you're going to do? Definitely slow down on the chat box. You're blowing it right up.
Where is this chat box? Fuck's sakes, man.
Who asked for the chat box? What?
So it should be right above.
At the bottom of the screen, there's a little icon that says chat, and if you click it, the chat box should open up.
Yeah, discharge temperature and pressure. High side pressure temperature after a condenser for subcooling. Retro from R22 to MO99, adjust the TX for higher superheat. Well, you want to check with the compressor manufacturer, especially if it's in warranty. I doubt it's in warranty, because MO99 is not always approved for compressors, certain compressors. So it's always good to follow that up. Sometimes I've seen it many times where the manufacturer of the equipment, who builds the equipment, says a certain refrigerant's approved, but then when you go to the compressor manufacturer, it's not approved for the compressor manufacturer. Doesn't mean it's not going to work. but it just doesn't mean that it's going to work very long either. Suction pressure, high side pressure, subcooling, superheat, outdoor ambient. Yeah, that's a good one. Indoor temp, amperages, delta T's. Fantastic. I love it. Okay, we're going to go through this. I could spend a long time on this, but yeah, Matt said these one, discharge temperature, discharge pressure, and there's going to be more of them. Air in, air out. I think John said that, delta T. Your subcooling at the outlet. So you get your pressure, temperature, convert it. Temperature in, temperature out. I'm not sure why I changed the color of the line there, but that's funny. So this one's probably a plug filter dryer, Gary.
Yeah. Who can do all this with their hands? Put your hand up if you can do it all with your hands.
Yeah. Oh, I met some people, some old school guy that could touch it, but that's 97. I'll put my thermometer on, it's 97. I'm like, what? Okay. Sight glass, if it has one, you want to check if there's moisture in that system. And this is something that so many from day one installations that if it's not installed properly, that system, you're going to run into lots of issues. Day one installation is the most important for a system. And when I worked for the compressor manufacturer, I seen it after a year, after 2 years, because of the install, those compressors were failing because of that day one install, even though the compressor didn't fail for 2 years down the road. And you can tell that by looking inside a compressor. It's pretty cool when you understand that stuff.
Sight glasses are a friend of the technician because it's the only window. Well, not the only window, because you got oil sight glasses and stuff like that. But it's a window into the system. And a lot of people say you don't need a sight glass, but I find sight glasses are very, very useful, especially if you know what that sight glass is supposed to be doing at certain times, because the sight glass isn't always clear, even during normal operation. There's times where a hot gas bypass valve could be open, and when it's feeding hot gas from the discharge into the evaporator, sometimes your sight glass starts to flash, but that's normal. So you really got to understand what you're seeing and what you're looking at. And when you know what it's supposed to be doing in certain situations, if it's acting differently, then you know there's something wrong with the system. So I love sight glasses for that reason.
Oh yeah, for sure. And they tell you so many different things. And depending on the application, like if you're doing liquid injection for like refrigeration low temp, it's great to have a sight glass to know if you got liquid going to those DTC valves or the TREV valves, temperature responsive valves. It's so important because it makes you can look at it quickly and check it and see it there. Because sometimes, like when it's just a pipe, you can't really measure across it to see if there's a temperature difference in certain areas, right? It's like if you go from this side of the sight glass or to this side, it's not going to be any different. Subcooling at the inlet of the TX valve, if you can do it, if you can check it. I know it's if you a lot of times you can't, but you at the outlet of the condenser subcooling, inlet of the TX valve or the metering device subcooling, or at least check the temperature there, because there should be really no temperature drop there. If you got a 5-degree temperature drop from the outlet of your condenser to the inlet of your metering device, something's going on. You got to figure that stuff out. Why is that happening? Where's it picking up that heat? Then air in, air out. Superheat. If you have a suction filter dryer, pressure in, pressure out, temperature in, temperature out. Remember, it's way worse. When do you put a suction filter dryer in? The air conditioning we'll talk about that one because there's different applications for it. When would you put
After a burnout?
Burnout. Okay, yeah, you have a bad burnout, electrical failure. You got to figure out why that happened. Most technicians don't know why. I didn't know why. I usually say it's electrical failure, the burnout, but there's always a reason why. There's a compressor issue or mechanical failure that causes that issue. But do you change this filter dryer? And when do you change this?
Yeah, right.
Why
Like,
do you change?
remember we went back a couple days, like changed it out, or it was like a day or two and changed it out. And then now it's just sitting there, it's piped in extra and it's just blocked off on this one.
Yeah. So you want to make sure that you go look at Sporlan, you'll go look at Alco or White Rogers, you'll go look at Danfoss, and you'll read their manuals, and they're going to say they want you to change that after a certain amount of time. There are instances where they'll say, okay, if it's a permanent installation, this much PSI drop. 1 PSI is the max, or 2 PSI, depending on it. You're going to have to look up those specs, but you shouldn't have it in there because we already talked about compression ratio, way worse than the suction line. And then always do, you know, an acid test. You got to check that oil. Got to check that oil. Most technicians don't. Now, if you're talking about like a little small system, you know, the acid test might be more than the system itself. Okay, but when you're talking about larger systems, you need to check that stuff. You need to put it in your quote. You need to write it down that I need a follow up to remove the filter dryer, and then do another check if you had especially a bad burnout or electrical failure. Very important. What do you think, Carrie? Do you do that? Do you put that in your quotes to follow up?
You know what? It's funny. I think last year I changed 1 or 2 compressors in total, and one was a bad burnout. And the only reason I knew it is because we did an oil analysis. We did an acid test. And because of that, we put in an acid suction dryer. And it hasn't been taken out yet, but it's being monitored. And it's fine right now. And if it gets to the point where it needs to come out, 100% it'll come out. It's just been one of those things where I know you probably see suction dryers in units for like 20 years that no one's ever came and taken out. But I know what you're saying, Trevor, that a lot of manufacturers say that after the system's been cleaned up, you should go back and remove it. This one here hasn't caused any issues with temperature drop across it, but I hear your point that maybe they should be taken out after the system's cleaned.
Yeah, if you're not going to go back, then you want to take it out. If you're going back and you're going to monitor it and it's a site that you have, okay, just monitor it, because you know there is a cost to that. And there's a good question in there. So you use a suction dryer and then take it out afterwards. So now, if you talk about a refrigeration application like a supermarket rack, they have suction filter dryers on them, and there's different ideas on it. Some people say you got to leave the filter dryer in. Some people say you got to take it out. For me, I would always have a felt dryer in. And the real purpose of that is to collect any copper, any shavings, so it'll protect the windings from that compressor. But that's another thing that needs to be checked. So, and these one would be called, like, they'll be cores. So you can actually take the filter dryer apart and put a core in and pull the core out, or put the pleat filter in and take it out. So maybe that's not where you were going with that, Justin, but I just said it anyway. And then compressor superheat. Oh man, this is the most important one, probably the most important check, or the return gas temperature check to the compressor. Most technicians take it, but they don't know what to do with it. You need to understand, if I take a temperature at, say, 18 here, and then I take a temperature at 23, you need to understand if this temperature is way higher, why? Is that suction installation bad? Is it running through? Is there too restriction?
Trevor, it's the TXV.
It's the TXV. Yeah, let's adjust it. Let's open it up. Okay, but you want to understand what's going on, because I've seen it many times. Chris Stevens from HVACR videos has lots of good videos on it. And there's a good example in one of his videos I watched. He was going across the roof, and all the pipes are laying across the roof, and he talks and he points at the insulation. Look at this insulation. He touches it and it flakes right off. And you know, in California, it gets super hot. So in the middle of the summer, can you imagine the amount of heat that's penetrating on this hot roof and absorbing it, and how much work and really heat that it's bringing back to that compressor? Are you going to replace all that insulation? The chances are it's not going to happen all the time, probably until you replace that unit. But something that you can quote your customers and say, like, this is important. Insulation's expensive. It's not cheap. I know that. But if they want their system to last an extra 5 years instead of an extra year and a half, you might have to do that. So these are just things to think about that maybe be able to throw in your quote.
I want to, since you said insulation and breaking and deteriorating, I want to give a tip to everybody. I've been changing a lot of insulation myself lately on refrigerant lines because of that. Because after so many years, the UV and the Armaflex just starts to flake, and you can touch it and it falls apart. I've been starting to replace it with K-Flex Titan. It's actually got an armored, not armored, but it's like a UV protective jacket over top of it, and it prevents that from happening. And I know sometimes the birds get at it and they peck at it and they take it and make nests. Since I put it on, I haven't had a problem, no deterioration, no birds pecking at it, and the stuff is in great shape still.
Can you put it on in place? Like it's
No, you got to cut it. You got to cut it
you have to
open.
cut it. Okay.
Yeah, you got to cut it open,
glue it, or-
and then glue it. Someone's
Okay.
asking me, do I find that it shrinks after time? I haven't found that it shrinks. No, that I haven't. I find that it is harder to glue and put together than the regular Armaflex, and you do got to take a little bit of time, and it's harder to bend and stuff because it's got that jacket on it. But if you're looking to replace the Armaflex with something, I highly recommend it because it's really good stuff.
Awesome. So we're at 9:01. We're going to continue on probably another 15 to 20 minutes. I'm real sorry about going over the time here, but we're just having such a great time and conversation here. We only got a few things left to talk about, and then we'll get into a Q&A. So mobile apps. It's so important to have apps today on your phone, having the knowledge, having it in your hand to really help you service and troubleshoot systems. So I know Gary has an app, HVAC Know-It-All. Great app, great community there. If you're not already on it, check it out. You need these other apps as well. Emerson AE bulletins. So these are the manuals for all the Emerson products for like Copeland and like their demand cooling and their core sense. If you work on any Copeland stuff, you need to have that app. You're going to learn why I feel like I'm so good. And I know I'm good at refrigeration now is because reading hundreds of these documents over and over and over again, and then go and apply it in the field. The Bitzer B-Spot app, another great app if you're working on Bitzer compressors. It has all their documentation in there. And same thing, like, yes, Copeland sells semi-hermetics, Bitzer sells semi-hermetics. Semi-hermetics pump the same way, they work the same way, but there is a lot of uniquenesses from them. I'll give you one quick example. Copeland under semi-hermetic says they don't like to see the discharge line temperature, what? 6 inches from the discharge. What temperature? They don't like to see it higher than. Anybody know? Throw it in the chat. Unmute yourself.
25, is it?
225. 100%. That's what Copeland doesn't want to see over 225. When you look at Bitzer, what does Bitzer say? 6 inches down.
Don't know that one.
Yeah, but that's okay. It's 250.
Oh, the pay scale. Let's hear it.
Yeah, it's 250. So there's different temperatures. And then when you get onto scrolls, Copeland scrolls, it's a lot of different temperatures. I always say 225 because it's a good number to say, but you'll see the cutouts at different points because the temperature, depending on the type of compressor, is going to generate a bit more heat. For in the semi-hermetics, Copeland says is about 50 to 75 degrees hotter in the head. Remember when I said that last point of compression is the hottest point? Could be up to between 50 and 75 degrees hotter.
And it's
So
all
Do they
about
give a
protect.
range on, like, say the Copeland mobile app? I was looking at a couple compressors I scanned. Do they give like a range for the compression ratio they want to see somewhere? Or
Well, when you go into diagnostics tool in there, it's going to tell you if you're running efficiently, not efficient, shut the unit down right away. So if you do the diagnostic tool and put in your pressures, pressures, amps and volts, then it's going to spit out where you're at in that operation envelope of that compressor. So you got to go to the performance chart in that compressor. So it'll say on the right hand side performance feature, and then go into like full performance or go into dynamic performance and put in your conditions, and it's going to spit out what your discharge temperature should be. Pretty cool app. So
yeah, that's wicked.
So play with it a bit more. Play with the apps, all the apps. You know, the Danfoss app. I'm loving this app. I didn't use it that much until like a couple years ago, and they got so many cool things on it. Like they got all their apps are in one, which is cool about their app. It's all in one. Copeland Mobile is if you don't have that and you're working on Copeland compressors, you're missing out. You need to get that. It's going to make your job easier. You're going to be able to find parts quicker. And so you don't have to really rely on a wholesaler. You can look up the parts yourself and say, I need this part number. Do you have it? Then call another wholesaler until you get the part quicker.
So you mentioned
And
it just a second ago, Trevor. I came in a bit late. You probably mentioned performance charts. You just mentioned it a minute ago, but the importance of diving into them now for actual seeing what your compressors are doing. So using the Copeland mobile app for that, and also the bits or B spot if anybody's working on bits or compressors. You can find your performance charts in there as well. It's been a game changer for me.
Oh yeah, yeah. I didn't use them before I worked at Copeland, and then all my training since I as a refrigeration mentor, this is what I talk about: performance chart, getting you in the habit of doing these things that we don't do as technicians. HVACR School for Techs by Techs, another great app. Lots of information podcasts there. Educational resources. I put this on every one of my trainings. So HVAC School, HVACR videos, R744 if you're in refrigeration, you want to start learning about CO2. The Tool Shed. Jerry Rollins, Eddie McFarlane. The Commercial Refrigeration book for air conditioning technician, Dick Wirtz. Great book. Like I have it right here. I go through it all the time. Just to review, to update myself and keep myself, current. Because I forget a lot of things. There's a lot of stuff about refrigeration and HVAC know-it-all. Great educational resources. Great educational resources. Is there other ones out there that you guys use? I'd love to hear. Shoot in the chat. Like, which ones do you use? Like on top of that, because these are the ones that I want to learn about more as well.
Geez, what's that YouTube channel? Okay, AC
Service Tech.
AC
Yeah,
Service
Craig.
Tech. Yeah,
Yeah, Craig's great.
That's another great one. I'm anybody that listens to what I do online. I'm not really good at sheet metal at all, and I watched him make a transition or a plenum, I think it was, and it was I watched it and I'm like, wow, it's that easy. I just watched him do it, and it took him like 15 minutes to make this plenum out of sheet metal. I'm like, man, why? That's not hard at all. I'm gonna start making plenums now. But that's a great channel to watch too.
We got the Triforce. I haven't heard of that one, so that's another.
I haven't heard of Triforce either.
I'm going to shoot a quick another poll here before we finish up. In refrigeration.
Sorry, whoever said Blue On too Blue On is awesome. Anyone who's afraid to call tech support, just call Blue On. These guys, nonstop, they're wicked. They're so
they're a good bunch of guys too. Yeah, for
awesome.
Sure.
So I just launched that one there. So in refrigeration, 1 ton is equal to what? And we got look at you guys are just so smart.
15,000 BTU.
Because this is what a lot of people would say, and I've heard it before, and I've trained wholesalers, manufacturers, so many different people over time, and back in the day when you say I need a 1 ton, well, they would say, oh, air conditioners are 1 horsepower, but then when you get down to low temp application, it took me years to figure it out, but it's like, oh, okay, well, I need a half ton or a half horsepower for a ton of refrigeration when it's low temp. You need to understand everything's in BTU or kilowatt if you're elsewhere, but I'm just going to end the poll. So you guys all crushed it. 12,000 BTUs, 1 ton. Everything's in BTUs, makes sense. Great job.
Could you guys just slide the 2 slides over? I was going to take a picture of the that app page. Oh, the one? Yeah, right there. Sorry.
Yeah.
Perfect.
Oh, and just so you guys are aware,
thanks.
My app there, HVAC Know-It-All, is the only one you got to pay for, just because I spent my own money.
Well, they should pay for it.
Well, I spent my own money up front to get it built, and that it's a $10 fee for the year, but it's to deter the BS that happens on Facebook where everybody says TXV or call a real tech. You know what I mean? That's why there's, just to explain if you guys don't know, that's why.
They should be
Plus,
charging more. They should be charging more.
maybe one day.
But
Maybe one day.
they should be
Shameless
charging
plug,
more.
it's the
But
best $10 a year you're ever going to spend.
yeah, I would be charging more if I were you. But so I'm going to throw in the chat. If you want to do a knowledge assessment, it's up to you. You don't have to. It's just something I built just on the program. It's in the chat there. You can click on it. And yeah, questions. We got. Sorry that we went over 11 minutes, but I'll sit on for another 9 minutes and take any questions you guys had. I really like the conversation for this evening for sure. Gary, how do you feel?
Yeah, man. I honestly, this has been awesome, because usually when I get on my laptop and the mic, I'm asking all the questions. I was just loving listening to you talk, man. It was great.
And definitely go out and hit HVACknowitall.com. Check out Gary's website. You know, tons of stuff on there, like tons of posts. You're always putting more content on there, and just keep consistent and persistent. That's what I love. Check out my website, refrigerationmentor.com. I got a ton of podcasts on there. I got videos on there. I keep adding more trainings and events. I'm starting a new event coming up probably next week. I did something for over 30 days. I think almost 40 days. It is morning coffees with Trevor. So every morning at 6:30, I was meeting with technicians. They were coming. We were hanging out. We were having coffees, chatting about refrigeration, HVAC. And I'm going to start something new coming up next week. So
For those that didn't see or didn't attend the morning coffees with Trevor, go check it out on YouTube. Well worth checking out.
Awesome. And don't forget, Trevor, if you guys, who here is from Canada and can make it to see CMPX, because it's going to be an awesome show. Trevor's going to be there. I'm going to be there. And there's
I'm going out on Friday.
There's a social hub that, if you look on the interactive map, it's somewhere in the middle of the floor, towards further away from the escalator. But it's in the middle area. There's going to be a social hub there, and we're going to be doing all kinds of interviews and
Where's
chats
it?
and stuff.
Where's it to?
it's in Toronto.
It's in Toronto.
Yeah.
Man, he's an East Coaster. I can tell right off the bat. what
Not
do you
making
mean?
that
Where's
trip.
it?
It's from down. He's from down east there.
Yeah, I love it. I love it. Yeah,
Where are you to, Trevor?
Cape Breton.
Nice. Stay away from me,
so
Cove, buddy. Stay away from me, Cove.
know all about it. Been there, done that. So CMPX Social Hub. We're going to be doing tons of podcasts. Me and Gary. We're going to be there. If you're there, come introduce yourself. We'd love to meet you. It's going to be a fun 3 days for me. I'm super pumped. I'm super excited about it. Just the networking, relationship building, the manufacturers that are going to be there, the associations, all the different people, contractors from all over the country are going to be there. And it's a great place to just start building relationships, building network. And it's so important for that in our trade, in our industry, because you never know who you're going to meet. And you never know like how you're going to build that, great relationship with someone that's going to help your career grow, start a business, who knows what it is. So it's so important to build those relationships. So hopefully I'll see you there. Awesome.
So I guess is anybody got a question? That's what we've been kind of waiting for, I guess, too, right?
Yeah.
It's crickets, man.
Yeah, it's crickets. It's all good though. It's all good. Yes.
Everyone's afraid to ask a question, but
So Matt, you ask one,
Yeah.
man. Come on.
Hey, I wasn't going to ask a question. I was going to say thank you guys for putting this on. Sorry I came late to the game, but awesome stuff from the two of you as always. Thank you, guys. And can't wait to see the two of you at CMPX.
I'm excited. Ethan, go ahead.
Is this going to be posted to YouTube like the rest of your videos too, so we can go back and review it after?
For sure.
Awesome.
Yeah.
Okay, connect with us on social media, all the platforms. Get on Gary's app. Come to CMPX and hang out. And let's get a conversation going. We'll talk again, everyone.
Thanks, guys.
Thanks, Trevor. Thanks, HVAC Know-It-All.
That was awesome.
Sorry, I don't know your name. I just know your YouTube name.
Oh, it says Gary McCready.